I was going to make somebody just do the welcome thing right away. Who's a bunch of travelers, right? I should have worked out something rude to say to begin with. But welcome back, Algebrists. It is Friday, September 5th. And we thought about this problem yesterday. It's hard to add up, right? Now, if you don't remember just from the lore, the legend, yesterday we talked about Carl Gauss doing this, and he was how old? He was 12. Okay, he did it in less than a minute, and he did it super fast. We're going to see what he did yesterday, or today. We're going to see what he did, and let's just jump in. For today, we're going to start talking about series. So here we go. We will come back, like this problem, we'll knock it out, but we're going to talk about a series. And because we're already in the arithmetic section, I don't think we really truly need to specify this in arithmetic series, but let's knock it out. How many of you guys have heard of a series in math? Not just a series of events, but a series in mathematics. Okay, that's kind of what I was expecting. Super easy. A series is just the sum, which means we're doing what to it? We're just adding stuff up. The sum of the first, typically, it could start somewhere else, but we'll say the first in our definition. The sum of the first n terms of a sequence. Now, when, if, and when, I guess, you wind up in calculus, there's 3 courses in calculus, just like there's 3 courses in algebra. It's Algebra 1, Algebra 2, and Pre-Calc. Those are the 3 algebra courses that you take in a high school sequence, or math sequence specifically. In college, there's calculus as well, and you typically, if you're going to pursue something with math, whether it's in STEM or just because you like math, you're going to see Calc 1, Calc 2, and Calc 3. There's 3 courses in the typical calculus sequence. The series thing is a huge, huge focus in both Calc 2 and Calc 3. So you will see this again, I guarantee it. We'll see it again this year, not in the calculus context, but we will see it. Now, as we look at these, we get a notation, and you guys know a few Greek letters, whether you know it or not, they show up as brain rot. I, for example, am an alpha, I believe, right? What else might you call somebody? Give me some more Greek letters that maybe you didn't know. Beta is another one. Omega. Any others? Sigma. Okay. Being sigma is good or bad, just out of curiosity? Okay. So check it out. Have you guys ever seen the Greek letter sigma? Okay. So we're going to look at this. We're going to talk today briefly about, and this doesn't have to be caps, we're going to talk about summation, which that word you've probably never seen, but what's the first root word of this? The sum. So we're just going to add stuff, yeah? We're going to talk about summation notation. Now, your book and most books refer to this as sigma notation, and we'll see exactly why here in a second. So check this out. If we want to write this up, this is just a way for us to write the sum of a bunch of stuff without having to write it all. Bless you. For example, if we scroll up, I didn't write all 100 terms, right? Do you agree that it would be absolutely awful if I had to do this all the way to 100? Like, that's a waste of time. That's terrible. It'd be nice if there were an easier way to do this. Turns out there is. We are going to use the Greek letter sigma. Now, just so you guys know, there are, just like our alphabet, there's uppercase and lowercase letters. Same thing in the Greek alphabet. When we use this, I'm going to draw a gigantic first, and then I'll do a small one, just so you can see. A sigma looks like this. That's the Greek capital sigma. Okay, lowercase looks like this. We won't use the lowercase in here, but those are the Greek letter. That is the Greek letter sigma. We'll use this one. So eventually, and I always try to draw mine nice, but people draw them like this. Totally good with it. Like, up to you stylistically. When we look at this, we're going to write one out. We're going to make sense of what it says. So we're going to have this sigma notation. So here it is. It's large. And then we're going to do a few things. We need to say, where do we start adding stuff up? So we use what is called an index to do this. I'm going to, underneath of this, write I equals 1. Now, we're going to label each part of this as well. Up above, and we'll label this first. This is the starting point, or the starting index. Now, it doesn't really matter what letter we use. I is what I prefer to use because index. J, K, doesn't matter. You can use whatever letter you want. Okay, the starting index, you may see this referred to instead as the lower bound. Okay. Up top, your summations are always going to have another symbol. This right here, n, is how far we're going. So what I mean by that is if we start at a lower bound, what do you think we're going to call this one that's up top? Higher might work. Is there a better word? The upper bound. Okay. And then we'll write this one this time. This ugly, or is that letter ugly? I don't know. This letter, what is this letter? Sigma. It's a capital sigma, so I'm going to use a capital S. Okay. We are going to use this notation, and it looks kind of ugly. Have you seen this before anywhere? Okay. Where, out of curiosity? In the homework on number 4 that you didn't do, right? Okay, cool. So, check it out. When we talk about stuff that we're doing an operation to, like we're going to be taking the sum, that's the short for summation, of something specific. A sequence is exactly what we're going to be taking the series, or the sum of. I try to include parentheses. In here, anytime that we have parentheses, I refer to this as the argument. So the argument of our sum is how I will refer to this. There may or may not be parentheses connected to it. I'm doing it now just to be nice. And we have some sequence. When we wrote the nth term of a sequence, I'm going to write it in pink just so we can recall. Oh, no, you know what? I'll write it here. How do you write the nth term? What letter do we use to represent the terms? Like something 1, something sub 2, something sub 3, A. And what is the index or the letter that we're told to use on this sum? We go to n. I like that. But what's the index? I. It's my starting index. I'm going to write a sub I in here. Now, this notation, all that this tells us is this is the rule of a sequence. Now, in our case, they're going to be arithmetic, and that's nice, the rule of a sequence. They're arithmetic in here, but there's lots of sequences that aren't arithmetic that mathematicians will worry about. Where do they wind up? What do they add up to? All that good stuff. Okay, this notation is super ugly, right? Just to see how it works in general, if we started expanding out this summation to see what we've done, where does my I value start? According to this, at 1. So the very first thing that I would do is I would say, hey, let's find, according to the sequence, what is a sub 1. And then this whole thing is the summation. So I'm going to add. If I started at the index of I equals 1, where's my next stop? First I do the first term, and then I'll take a step and I'll do which term? The second. Notice, this just tells me where to start. I will keep counting up with each index position, so the first, the second, the third. Eventually, I'm going to get to a stopping point. And I don't have a number for it here, but what do you think the last term I'm going to list is based on everything we have written here? Say it again? So if this were 100, I would agree with you. Do you agree that we start at 1 and we go all the way to n? So a sub n. Now, entirely up to you if you want to write this down. We're going to learn how to pronounce this. Okay, I'm not going to do the right side because that's so ugly, but when you look at just this side of it, right here, what we are seeing, word for word, the appropriate way to talk about these things, is this is the sum. And you could say summation if you wanted to. I'd prefer just the 3-letter word. The sum from I equals, where did we start? 1. And we go to what? N of what sequence did we, in this example, use as the argument of our sum? A sub I. Perfect. This is the sum from I equals 1 to n of a sub I. Okay, that is hard to think about, hard to do. Anybody look at this and go, oh my gosh, this is a terrible idea for me to be in this class right now? Okay, not as many as I was expecting. You're wrong. You're going to see this is really easy. Let's work just expanding and working a couple basic ones, and then we'll move up to more complex ones. So let's do some examples. And I'm just going to name this one expand, and you can appreciate how clever this guy is. Zed likes it. So it's not just an example called panned, right? You guys tell the dumb joke I'm making? Baller. All right, let's do one. I'm going to make one of you read this. So, like, read it out to me in just a second. I want this thing. We have this lovely sigma, and we start here, and we go to this, and we're going to do this. It looks like it's going to be terrible. I promise it's not. This is going to be so nice and so easy to do. First thing I want you to do, 15 seconds, I'm going to call on one random person. I want you to read me this mathematical statement using words, just like we did up here. I want to chat with your neighbors, see if you guys agree. I'm going to go 15 seconds. I'm going to call one random person. If there's a reasonable number of terms, it is completely worth it to just write it out, especially when we're learning it. Let's write this thing out, and we're just expanding it, and we'll actually solve it, but I'll do everything new in red. What index did I start at? 1. So we don't have to do this for every single piece, but check it out. I need to know the first term of the sequence. Some of you can do it in your head. Some of you might not be able to. Here's what I want to be very clear that we're doing. I'm going to use brackets so they don't look ugly. Here's the first term that we're going to write. 2. And what am I plugging in for I in this very first term? 1. This is a sub 1. This is the first term in my list. Plus, I'm going to write out one more like this. 2 times what I value would we be at now? 2. Okay? I want you guys to spend like 30 seconds and finish this. Don't go past our upper bound. You stop at some particular I value. Which I value are we stopping at? 4. Cool. I want you guys to do it. I'm going to give you like a 10-second head start. I promise I will not make you do this every single time. If you are struggling or done, look up at the board, see if we've done the same thing. I just plugged in 1, 2, 3, and 4 for the I values. Nothing else changed. Anybody have something wildly different than what I have on the board? Okay, I'm not going to make you do this every single time. Let's expand a little bit more of this, and let's check it out. What does this first term turn into? Because it's here, like I can see it, but it's not very helpful mathematically for me yet. What's 2 times 1? Plus 1? So that's 3 plus, what's 2 times 2? Plus 1? 5. Plus, what's 2 times 3? Plus 1? And you've probably noticed there's a pattern at this point in time. Without even having to calculate the next one, can you tell me what it is without actually doing this? It's a 9. Did we do the first 4 terms? And we're taking the summation, so let's just add them up. What's 3 plus 5? Plus 7? 15 plus 9. Look at that. We just found our first summation. Okay, Sonny, you did not look super pleased with this a minute ago. Does that make it feel better or worse? Or you're still not very comfortable? Okay, let's try another one. And then we're going to jump into Gauss's world. So this time, I want you guys to do the sum, and you have to pay careful attention. I'm going to ask somebody to read this one. Does the letter that we use for the index matter? No, so check it out. I'm going to throw a curveball at you. We're going to go the sum from k equals 2 to 5 of, let's do k squared plus k. There's a really easy mistake that one might make here. Before I say I want you to try this, what's changed about this new series that we're doing? So it's squared, that's certainly different. Anything else? I changed it to a k. We start at which k value? 2. So we don't do 1 this time, right? Okay, I want you guys to expand this out and find me the summation. Do you want me to do the first term with you? Okay, you can ignore me if you don't want it. Where do we start at, Kennedy? Hey, K is for Kennedy. Look at that. If you're having trouble with that one, just finish this for me. This is the sum from k equals what? The sum from k equals, let's start at 2. This is telling me where to start. So I'm going to do some mental math, if you guys are okay with that. I'm going to plug in which value for k first? 2. What's 2 squared? Plus 2? It's 6. This is 2 squared plus 2. The next one would be 3 squared plus 3 squared plus 3, because we're just plugging in a 3 for k now. 9 plus 3 is 12. So this is the a sub 2 term. I know it's weird, but we started at 2 this time. Here's the third. Go ahead. So we just did 3 squared, because remember this is 2 squared plus 2, because we started here instead of 1. 2 squared plus 2, 3 squared plus 3.
Why would you? So it'd be 3 squared, but why would you add 3?
Because we're adding k to it, right? And on the second step, because we started here, I'll write it out. I'll expand it just like we did the first one, okay? All right. The first, we start at 2. Do you agree it's 2 squared, because I'm plugging that in for this k. And then what do we add to it? Because that was k, right? And the next one is going to be, now we're at 3. It's 3 squared plus, what's k this time?
Oh, k changes?
Yep, k, we're counting up from k. So here's a sub 1, here's a sub 2. Each time k just jumps 1. So 3 squared plus 3. The next one is going to be 4 squared plus 4. And the last is 5 squared plus 5. You do not have to do it like this every time. If you are confident in your mental math, I'll trust your confidence. On a test or quiz, which there's no summations on your quiz that we're going to take first, you don't have, like, if you can do a mental math and write it out and expand it, I don't need to see your scratch work. But if you don't show anything at all and just the answer, I'm not going to give you full credit. Cool. All right, let's work this out. 2 squared plus 2 is 6. 3 squared plus 3 is, 4 squared plus 4 is, and 5 squared plus 5 is 30. Let's add these things up. What's 20 plus 30? Plus 18. Try again. You added 12. You're right. 62 plus 6 then? 68. We just got the sum. As long as you can pay attention to 2 things. Where does your index start? And how high does it go? You're going to be golden. Now, if we only have 3 or 4 or 5 terms, there's not a huge issue with like actually expanding it out. These aren't crazy hard. With that in mind, let's revisit that Gauss problem. And I'm going to, before we do that problem, I'm going to make one little comment. Mathematicians are lazy. Is that true or false? So you're not going to offend me. I think they are. I think they're super lazy. And you'll see that with all the notation stuff, right? Like mathematicians don't like to write. Regularly, it is common to use S, capital S sub n, instead of that whole summation if index starts at 1. Okay, really common to do this. So, when we look at this, if once we write it down, we kind of see like, oh, yep, this is a summation that we're doing, it is really common to switch to this notation right here instead of writing this big ugly symbol over and over and over. So, let's do Gauss's problem. First thing that I want you to do is using sigma notation. On C, there's going to be 2 parts. First part, I want you to write the sum. And I'm going to call it the summation, but you can certainly just write the sum or just the sigma, right? You can write this of the first 100 integers. That is 1 plus 2 plus 3. I'm going to say the first 100. We'll say natural numbers. That way we don't have to worry about restricting it anywhere. Okay, here's your first challenge. I want you to write me and fill in the missing stuff here. Just to make us consistent, let's all start at I equals 1. And I want you guys to finish the upper bound and the argument of this. I'll give you guys a second. I'm going to come around and like look at your pages, be really judgy. Good. What's going to make this list so that the first one is just 1, the second one is just 2? You might not recognize it right now. When we see it, you will. Anybody else struggling a little bit? All right, let's knock it out. I start at 1, and I want to add all the way up to the what number? So where should I put my 100? To the top. Here it is. Now, this one can be hard to see. Do you guys agree? Don't write it in pink here. Do you agree that this is an arithmetic sequence? Okay, like dot, 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 all the way to 100, yeah? If I wanted the first one to spit out just a 1 and the second one to spit out just a 2, I don't need any like 2i, blah, blah, blah. I don't need an I squared. If I just put an I in here, just this, is this going to generate the list that I need? Like, if we started expanding, first one is going to be 1, right? The second one will be, and the third will be, hey, it's going to do my whole list for me. This is the rule for this sequence. It's a boring sequence, but we can do it. Okay, now we know that this, just purely for notation, I don't want to write this over and over and over. Do you? So what can we use for this then? I'm going to use S sub n. Okay. This is just a time-saving notation thing. If you want to write the sigma notation over and over, feel free. This is faster. So here we are. 12-year-old Gauss was given this problem. And he didn't write it down like this, right? The teacher just said add up the first 100 numbers and left him to it. Less than a minute, he came back and he had an answer. Less than 1 minute. Let's see how he did it. So here we go. I'm going to make my stuff a little less bold. Let's just start expanding. I'm going to say S sub n is equal to, and if we expanded this, it does turn into be 1 plus 2 plus 3 plus dot, 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 all the way up till eventually we get to 100. Okay, have we really done anything to help us solve it yet? Not yet. We're getting there. Now, it's not obvious until the first time you see it. I'm going to switch colors just so it stands out a little bit more. And let's go blue, because the Cowboys lost. I'm going to do something that seems wonky real quick. I'm going to add straight down. And as long as I do it to both sides, I'm okay, right? Like, I can add something to both sides of an equation. I'm going to add S sub n. And it seems like, oh my gosh, why would you do this? But let's expand this one, but we're going to just shift our thinking a hair. Instead of writing 1 plus 2 plus 3 plus dot, 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 could I go the other direction? Could I say that this is 100 plus 99 plus 98 plus dot, 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 all the way until I get down to plus 2 plus 1? Is this the same summation? I just switched it around. Okay. Here's the brilliance of 12-year-old Gauss. Does anybody, other than Liam, because he might remember what we did last year, anybody who took my science class last year, we probably did this one random day. I don't remember why, for fun. Can I add these? I think so. I'm going to draw a bar here because I'm going to add them. Now, it feels weird to do, but if this had been x plus x, what would we get? What's 2x, right? If it was L plus L, it'd be 2L. This is just a variable. It's some representation of something else. What's S sub n plus S sub n? 2S sub n. No square. We only get squares if we multiply. Before we do the other side, questions here. This is the weirdest part. Okay. Well, let's start looking at this. Gosh, did I do anything helpful, you think? If we just add straight down, let's just see what happens. What's 1 plus 100? Plus, what's 2 plus 99? Oh. What's 3 plus 98? Interesting. Dot, dot, dot. 99 and 2? And the last one is again 101. Here's the big question. How many 101s did I have to write here? So if I want to add 101 to itself 100 times, is there a more concise way to write this? Oh, can we just multiply it by 100? So let's just see where this takes us. 2 then of S sub n is equal to 100 times 101. Multiplication is just repeated addition. We're going to use it. Everybody's still on board. one step away from solving this. If I want to solve for the sum of the first 100 terms, S sub n, algebraically, what would you do, Mark? We made eye contact. How do I solve, like this looks ugly. What if it was this? And I wanted you to solve it for x.
First, multiply 100.
So we could, and then you're going to have to divide by something as well, eventually.
Divide by 2.
Okay, this is the same thing. I'm going to divide both sides by 2. I then wind up with S sub n is exactly equal to 100 times 101 over 2. Is it easier to do this multiplication, and however you see it, than it would be to physically write out all 100 terms? For sure. Anybody know what this number comes out to be? Anybody have a calculator handy? Cool, that's right. Double check for me. I think it's 5,050. Man, we can use this technique to find arithmetic sums super easy, or series rather. Now, this is all fine and dandy. Will this work with every arithmetic sequence, do you think? It will. It will work with every single sequence that we use. We just have to think about where these terms come from. To generalize from this rule, and we're going to think about this for a second, we'll write one last statement. From our original sequence, did this have a representation? Was 100 important in our original sequence? What was it? So that's like n? Everybody agree with that? What about 101? It looks like it's n plus 1. Everybody agree with that statement? I'm cool with that. N plus 1. And it's all divided by 2, right? So here we go. As we look at this, we are going to give ourselves a nice generalized rule. Super important last statement of our section. The series, or we'll say the finite series, or finite arithmetic series. Formula. Okay, this is an important one. When we look at this formula, it turns out that there is a really, really nice way that we can knock this out, and without spending a crazy amount of time, let's knock it out. Given arithmetic series, the sum of the first n terms is, and I'm going to let you guys catch up before I write the big conclusion here. Cool. All right, check it out. I'm going to use S sub n for my shorthand notation. S sub n. It turns out every single time, and you can play around with this, or if you want help, we can verify it. We simply take the number n, whatever it is, and then we add the first term, a sub 1, plus whatever the nth term in our list is, a sub n, and we divide it by 2. Now, Michael a moment ago noticed that it was n times n plus 1, but if we look closely, is this the same thing? Is 101 what we get when we take the first term of our regular sequence plus the last term? It's exactly what we get, right? So, one problem, should we do, actually, I'm going to switch this up. You're going to do one example for me, but you're not going to do it in your notes. You're going to do number 4 on your homework right meow. Cool. You will use this formula. The hardest part, you just need to make sure you get the first term and whatever term you're looking for. I want to use this formula rather than expanding it out whenever possible. Cool. Number 4, I hear people opening their books. If you don't have it, I'll put it up on the board for you. Number 4 is right here. It looks like the sum from n equals 1 to 5. Notice the letter changed again. Doesn't matter. Cool. I want you guys to work this problem. I'm going to give us like 2 minutes. When you get an answer, just let me know, and I will come check, and you will be helping your neighbors. Cool. let's just jump in. We are taking, and I'm going to just call it an example. You guys can do this on your homework. I'll take your homework here shortly. We're finding the sum of the first how many terms? 5. Okay, so let's think this out. Our rule, a sub n, we can find that by doing, is it 2n plus 1? Okay, this is our rule for our sequence, right? The argument of our sum is what we would call that. Everybody okay with that language and clear on that? Terrible way to ask, because if I ask one that's only yes or no, I don't really get any good answers. We have the argument that is the sequence itself. So here's the sequence, the rule that we're following, 2n plus 1. Can you plug in n equals 1 to get me the first term? 2 times 1 plus 1. What's the first term of our sequence? 3. We also need not just the first term, but we need the nth term, or the last term that we're trying to add up, which in this case would be a sub what number? 5. The fifth term of this sequence is 2 times 5 plus 1, and it is 11. Questions here about how I got anything? Okay. We're going to write it. I don't know that we always do. In this particular problem, we're trying to find the sum to what n number? The highest n value that we're going to. 5, our upper bound. So check it out. Do we have n? Do we have a sub 1? Do we have a sub 5? Do you know what 2 is? Okay, cool. Look, we have all these pieces. Let's just knock it out. S sub 5 is equal to, gosh, what's n again? Try again. 5. And then I'll write this out this time. The first term was 3 plus, what's the fifth term? 11. And all of this gets divided by 2. Some of you might have skipped work. I normally will, but I'll try my best not to. Can we all agree that this turns into a 14? Okay. And then purely out of curiosity, because I like to see how people do mental math, how do you guys mental math this? Like, you can probably get an answer here. How would you do this problem, though? You do 5 times 14 is 70 divided by 2? Does everybody do it that way? I don't do it that way. We're going to get the same answer. You do what? Okay, so we might just do it on a calculator as well. I'm not your arithmetic teacher. I would encourage you, like, there's always benefit to being able to do stuff in your head, but it's not a requirement. I don't do that either. I look at this, 5 times 14, I can do it, but I'm going to divide it by 2 in the end, right? Is there anything that goes into 14 and 2? 7 goes into 2? 2 goes into this one 7 times, and goes into this one once. This is an easier multiplication, and we're going to get the same answer. What's 5 times 7? Divided by 1? 35 still. Whether we do 70 divided by 2 or we simplify the fraction first, doesn't matter, we get the same answer. Okay. Looks scary. Looks like the fanciest math you've done. Is it crazy hard? Good. All right. So we're going to go really quickly, just looking. We're only going to, I'll read through your answers 1 through 3. Do you guys have your homework in front of you right now? Okay, here we go. I want to know, if you found the common difference, I think you'll probably find the next 3 terms reasonably well. Does that seem okay to you guys? So when we're checking, I'm going to check 5 through 11 is what I'm going to check. And we're just going to read the common difference. I'll check your next 3 terms. Did you guys check all your odds? You should. But let's look at that. Number 5, common difference. 1/4? Cool. Number 6? -5. The common difference on number 7. 12. The common difference on number 8. -1, the common difference on number 9. 2.2. And the common difference on number 10. 8. Okay, last question. I just need a dollar amount. How much money is that person going to save? How much? We will look at that problem again. Anybody get 294? Okay, we'll deal with that problem, but I want to get you started. Please, on the top of that page, make sure your name is on it so it doesn't just go into my grill and you get a 0. Minus however many, just from 5 through 10. So if you got all of those, just put -0 on it. Once you have -0, -1, -5, whatever it is, and your name is on it, pass it to the front of your row, and I'll come take it. 11 is 294. You guys just added 4 over and over, didn't you? You did 30 plus 48 to get 78. So it should be 30 plus 34 plus 38 plus 42 because he's depositing $4 more each month. Okay, I will take those.
What's your name?
All right, last call. Anybody else have one? Okay, so you probably noticed we only have like less than 10 minutes left in class, or if you don't, now you do. For the next remainder of class, I know that's not a time weird. All right, for the remainder of class, I'm going to give you guys a quiz. Now, here's the deal. Normally, quizzes in here, they and historically have taken like a whole hour, so they just essentially give you a test for half the chapter, so that you prep for the second half of the chapter. This is essentially the same. I will try to do more frequent quizzes that are much shorter, so that we get more padding, more cushion. You can demonstrate smaller pieces of knowledge at a time. We'll work up to the longer tests and stuff as we go through. But for this first one, about 80% of you guys have never seen a quiz or know how I style things. Because of that, I don't want you to come in like completely blind and have to work something that you have no idea what to expect with it. For future quizzes, I will help you make a note card. Like we'll review how to study math because I don't know that everybody knows really how to study for a math test. I'm going to pass this out. I want you guys, until you leave, to work on this from memory to the best of your ability. You won't be able to do all of them. Maybe you will, maybe you won't. Don't care whether you can do all of them from memory or not. You will then take this home, and this weekend, your assignment is going to be to finish this quiz. You can use open notes. You can use open book. You can work collaboratively so long as that entails each of you understand it. No copying. Cool. Once you leave, you're free to use whatever resource. If you wind up using AI of some type, which I would encourage you not to because they're typically pretty bad at math, if you use AI or the internet to help you answer a problem, that's okay, as long as you're using it to learn how to do it. If you do it with a method that we have not discussed, I'm okay with it, but I'm going to ask you to describe it to me when I grade your quiz. If you can't describe it, what do you think I'm going to do? Well, yeah. Don't cheat. Use resources. Cool. 10 minutes, you guys can work, talk to each other, but I want you to try to get through just the remainder of class just from memory, without your notes, without your book. Once you leave this classroom, you need one?
Oh, no.
Oh, okay.
I have a question about what predicted.
Ooh, love it. So I keep track of stuff to see where people's confidence levels are with things. This one, I did not know if it was going to be a team quiz initially. I make people predict. So when you hand in a test or a quiz to me, normally, I'll say, how do you think you did? And you just give me a percentage. So you won't know until you're done, right? Like if you go through this test and you're really confident, you might predict somewhere between 90 and 100. If you work through this and you're not really confident at all about any of them, you might predict much lower. Okay, I keep track of this so that I can see what was your prediction, what was your real score, and what is your perception of your ability to do math. Cool, it's just data for me. Give it real predictions, no dumb ones. Nobody's gonna get a 67, like it's not gonna happen. So don't predict 67. Give me real predictions, unless you think you do 67. Cool?
10.
All right, you guys can move desks. We got like 5 minutes for you to get a head start on it. Caller. You can chat. It's not purely quiet time. I'm going to turn on some music, so it's not purely quiet time.